got a function f. G of x is the integral of f of t from 0 to any value x. So first thing, it wants us to find g of 4. So I'm going to just replace the x with 4. So this is going to be integral from 0 to 4 of f of t. So that is looking for this piece and this little piece right here. This piece that's below the x-axis, notice it's got to be negative. But then if you notice, this and this piece, they are the same area. So one's above, one's below the x-axis. So they're actually going to cancel each other out, meaning that it's going to become 0. So really all you need is the area of this rectangle, which is going to be 2 times 2, which is 4. Okay, g of 3, same idea. So g of 3, is, let me erase this, only going from here to here. So that's just the trapezoid that we've got. So area of the trapezoid is 1/2. This is your height. And then your two bases are 2 and 3. So 10 divided by 2 is going to give me 5. Okay, local min. Anytime we ask about mins, max, step 1 is find your critical numbers. That is where the derivative of the function is equal to 0 or possibly does not exist. But I know that f of x is the same as g prime. The only place where f is 0 or does not exist, there's no place where it doesn't exist because there's no holes in the graph, so we won't even worry about that. So your two values are going to be at 3 and 5.5. Those are my zeros. Now I'm looking for a minimum. In order for a minimum to occur, I know it has to change from negative to positive. So notice that f only goes from negative to positive at 5.5. So your local minimum is 5.5, and let's justify our answer because f of x, which is really g prime of x, changes from positive to, this is min, from negative to positive at x equals 5.5. Okay. Next question is asking about absolute maxes. So again, when we talk about maxes and mins, we always need to look at critical numbers, which we already found from above, so we don't have to redo that step. But we just found from above that 5.5 is a minimum. It's not even a maximum, so we know that's out. We already figured that one out. So 3 is your only possibility in the interior. And then remember, the other piece that we need to check for absolute is the endpoints. And your endpoints here look like they are 0 and 7. So I need to figure out at these x values, 0, 3, and 7, I want to know about g, so I need to figure out what these g of x values are. Okay, remember going back to the top, g of x is really just going from 0 to x of f of t. If I plug in 0, bounds are the same, so this is 0. If I plug in 3, we just found it from part B above, we figured out it was 5. So the only one that you have to do is figure out g of 7, which is all of this. And if you do the geometry here, you should end up with 3.5. So the highest value is 5. So the x value where that occurs would be at x equals 3. So make sure you just answer the question. Okay, last one here, they give us a function for h. They want us to find the derivative of h. I have x's on top and bottom, so that tells me I have to use the quotient rule. So h prime is derivative of the top times the bottom minus the derivative of the bottom times the top all over denominator squared. I want to know what happens at 3, so let's go ahead and just plug in 3 for x. This gives me 10 f of 3. Bottom ends up being 10 squared, which is 100. And now I just have to get these values from my graph. F prime of 3 is the slope of this graph at 3. So let's see what's happening at 3. This is a straight line. Notice I'm going down 2 to the right 1. So it looks like f prime of 3 is going to be negative 2. I have 10 here. And then f of 3, if you look at the graph, ends up being 0. So this is going to give me negative 20 over 100, or negative 1/5 if you simplify.